Lesson 6, Units and Measurement, Electrical Charge. Our objectives for this lesson are to be able to explain what we mean by the concept of fundamental charge, as well as to be able to calculate the total charge that's built up on an object. So let's start by taking a look at electrical charge. Electrical charge is sort of like time in that we know that it exists, but it's very difficult for us to define. So all you need to be aware of is that the MKS unit for electrical charge is called the Coulomb, named after Augustin Coulomb, a French scientist. It is abbreviated as a capital letter C. Something else about electrical charge is that even though we're talking about fundamental units, the Coulomb is not a fundamental unit. It actually comes from another unit. That also gets a little complicated. So as I said, you just need to know that the fundamental or basic unit for electrical charge is called the Coulomb. We do, though, have what we call the fundamental charge. Remember, the word fundamental means basic. The reason that this is called our basic charge is because it is the charge on one electron or one proton. Since protons and electrons form the building blocks of the matter that we come into contact with every day, therefore, it is our fundamental or basic charge for everything that we would be working with. It was once believed to be the smallest charge because protons and electrons were thought to be the smallest subatomic particles. We have since found other subatomic particles, things that really don't build the matter that we come into contact with regularly, so we still call this the fundamental or basic charge. Since the electron was the first subatomic particle to be discovered, we represent the fundamental charge as a lowercase e for electron, although the proton has the same exact charge except that it's opposite. The value for this is very small because remember, protons and electrons are pretty small objects. It's 1.6 times 10 to the negative 19th coulombs. So that you don't have to worry about memorizing this number, you can put this on your formula card under basics. You can label it fundamental charge and put E is equal to 1.6 times 10 to the negative 19th coulombs. We can then use this to help us solve some of the other problems. For our first example, we want to figure out what the total charge is of 5 times 10 to the 23rd electrons. Now normally we have a formula. In this case, we're not really going to work with a formula, but more with an idea. Let's take a look at a different example first. Let's say you have an orange, and that orange had 5 seeds in it. And you had 6 of those oranges, and you knew that each orange contained 5 seeds. To figure out the total number of seeds, you would take the total number of oranges, 6, times the number of seeds in one orange, 5, and get 30 seeds. We're going to do the same thing. We know that we have 5 times 10 to the 23rd electrons. We know how much charge each one electron holds. So we're going to multiply the number of electrons that we have by the charge on one of them, or 5 times 10 to the 23rd times E. That's kind of like our formula. Then what we can do is we can substitute the value of E into our letter. 5 times 10 to the 23rd times 1.6 times 10 to the negative 19th coulombs. Then putting that in our calculator, we get 80,000 coulombs. Or, if you want to keep it in scientific notation because these other numbers are in scientific notation, it's 8 times 10 to the 4th coulombs. Either way of writing your answer is acceptable. Let's try another example. The nucleus of a boron atom has 5 protons. What is the total charge on the nucleus of a boron atom? So remember, The charge on one proton is the same as the charge as one electron. It's E. And we have 5 of them. So it will be 5, the number of protons, times E, the charge on one of them. We can then substitute our value in for E, multiply, and get our answer, 8 times 10 to the negative 19th coulombs. This is what the problems will be like on your problem set.